In my review, the acoustic reference was at the tweeter. Now, this is the frequency response measured at about 85.5 decibels at 2.83 volt, 1 meter. So pretty much right on with the spec of 86 decibels. You can see its frequency response linearity is within about 3 decibels, plus or minus 3 decibels. On the low end, the F3 is at 69 hertz and F10 is at 38 hertz. And the thing that I want to call attention to here is this sloped mid-bass, mid-range transition region. So it's really right around here. It's likely designed to be placed near a wall. And I knew that from looking at the data, but then I went and looked at the manual and lo and behold, they say started off about a foot or 2 feet from the wall. I would recommend a foot. I think that's probably where you're going to be the most happy with the transition from the mid-bass to mid-range area and that 200 to 300 hertz area. I think if you bring them out far into the room like I did initially, what's going to happen is you're going to have this sloped off bass and you're going to be wondering, where's the weight of the vocals? Where's the punch of the mid bass? You're not probably going to get that if you pull them too far out. This is the CEA 2034 data set. What we have here again is the black on axis and the green is the listening window. These are the same graphics that you saw before, but now I've added this early reflections and the sound power as well as the directivity indices down here. This directivity, the sound power is excellent. And the other thing that I noticed was there's this dip in this lower treble region, upper mid-range, right around here. When you look at the directivity, you can see that it's perfectly smooth. So my hunch is that this was baked into the design on purpose, maybe to take off a little bit of edge or attack, maybe to take off some sharpness from certain recordings. I've learned that some manufacturers will purposely do those kind of things. Now, it's easy to tell when a manufacturer wants that to be the case versus when they don't want that to be the case. And the way that you would notice that is if these blue line or this red line right here, if they dropped and they changed the way that they're shaped, that would indicate that there's something going on in the crossover region, but it's not necessarily for the best. However, in this case, both of these lines are quite linear. This is really good. This is the estimated in-room response. And to kind of give you an idea of how I heard this speaker, I put this blue line in its place. Now, what I've noted here, especially pay attention to this lower frequency region. Now, this is all without a room. This is anechoic data, which means that I don't have the luxury of having the wall behind the speaker provide additional reinforcement that would otherwise cause this black and red line to start trending more upward before it start rolling off around here. Outside of that, I wanted to mention, again, the upper mid-range kind of lacks some slight attack, maybe some detail. Now, I noticed that other people might not, and you may be happy with that. But again, this does look like it's actually baked into the design. And then looking at the black line, which is directly on axis, we can see that the treble is a bit hot when it's aimed directly at you. And that's why I recommend aiming slightly off axis, red about 30 degrees. And to give you a visual cue of what I'm talking about, black is in 0 degrees, red pointed out away from the listening position is 30 degrees. This is the horizontal directivity at about plus or minus 60 degrees overall. Look how freaking good this is. Now, you're probably never going to get this. I shouldn't say never. I will just say, in my experience, if you get this from a two-way design, there's probably an electronic crossover, and they might be running the risk of crossing over that tweeter too low. If you get it from a three-way design, it's probably going to be a pretty expensive three-way design. Otherwise, you're going to have to go coaxial to get this smooth handoff. Like there's no dip or change or anything like that through this region. You do notice that there's most likely some sort of diffraction element. That's why you get a dip around 9 to 10K. I'm okay with that. Now let's look at the vertical, and it's kind of the same. This is what I meant by you can walk around the room and you're going to have pretty much the same overall sound. And I want to give you a quick example of what I mean when I say that, this red area looks really good and that's what we want versus something like this, which is a 2.5-way design. And you'll see that this red right through here, yeah, it looks all right, but it's really narrow, which means that you got to sit like within a very limited window on that tweeter axis. And then if you go above or below that, the SPL drops off significantly. This blue, green, yellow, orange area, that's lower SPL compared to listening directly at the tweeter level. So if you stand up, you're going to lose about anywhere from 12 to 24 decibels within just a small window. Whereas if you go back here, you can see that you've got a large window you can listen within. And even if you go even higher and higher, like to 70 degrees, you're still only about 9 dB down. Whereas with this guy, if you go to 70 degrees at the crossover region, you're about 24 decibels down. Harmonic distortion, 86 decibels at 1 meter, well below my personal 3% threshold, and well below 1%, and pretty much below, 0.3% at negative 50 through the mid-range. Like, this is crazy low. Next, we increase the volume to 96 decibels, and we're still really, really low. And just as an example, here is the same speaker I showed you a minute ago. It's a 2.5-way design at 96 decibels. It's higher, right? Like, instead of 0.3, it's about 1. Now, actually, this is still pretty low, but going back, you can see that there's a significant difference in the overall distortion. But to be fair, the other speaker is only like $2,000 or $3,000 a pair. They're not $87,000. Multi-tone distortion, again, extremely low full band. And I think this actually now is the lowest multi-tone distortion measurement that I've gotten. That includes against the PS Audio FR10, which had very low multi-tone distortion in the mid-range. I'd have to double check. And then the Kef Blade 2 Meta. I did double check that one, and I know this one has lower distortion than that. So right now, the TAD-CR1TX is the lowest distortion speaker that I've measured to date. What about compression? Okay, so in compression, you run out of some steam in the high frequency. At 102 decibels, I don't know if that really matters so much. On the low end, I'm perfectly fine with half a decibel loss between 76 decibels output and 102 decibels output. 26 decibels of dynamic range, I